So welcome everyone. My name is Florence Poirel. This is actually my first time on stage, I want to say since before COVID, but actually pretty much in much longer time. I am not from the Google Paris office. I'm located in Zurich usually, so I'm a bit of a tourist compared to you all, I guess. I have been at Google for the past 9 years, and I am now the Developer Community Programs Lead for Europe and Israel. So for the people who don't know, the Google Developer Ecosystem team leads a few programs. We have the Google Developer Groups, Google Developer Student Clubs, Women Tech Maker, the Experts, and the Accelerator program, which is for startups specifically. The goal of our team is really to enable developers across the world to develop their technical skills with Google technologies, to help with their career, and to help as well enabling the world with new technologies that can help with all of the various issues that our world is facing. All right, so today we are focusing specifically on accessibility. This event is the first one in Europe for our team. Accessibility in product development is extremely important, and we decided to share some of the knowledge of what we do in Google and the tools we have available to developers outside in the community. This is part of a roadshow. So we had Berlin last week, Paris today, and London next week. And this is something that we hope to do more regularly for all of the developers in the region. We have some great speakers tonight. So Christopher Patnoe is the head of accessibility and disability inclusion for EMEA at Google. He leads Google's effort around accessibility of products, people, and partnerships. Guilaume Laforge is developer advocate for Google Cloud, and he engaged in cloud accessibility features especially. And finally, we have Emily Meng, who is a software engineer for Maps JavaScript API team. We had a fourth speaker, Hugh Song, unfortunately, who was not able to travel today, so you'll have a bit more time for Q&A. So here's the agenda. We're going to start with the keynote from Christopher. Then Guilaume is going to tell us about how machine learning can contribute to improving accessibility. A short break, and at 8 we're back for a talk by Emily on building for accessibility in reusable components. And then we hope to meet you all for some networking and drinks and snacks. So now, let me introduce Christopher Patnoe.
Hello. Thank you for inviting me to come here. Thank you for giving me an opportunity to share with you some of my thoughts, some of my mistakes, and hopefully inspire you with what's happening around accessibility. What I want to do is share with you some of the areas where we've been focusing to give you a story of progress, not perfection, because you're never going to make everything perfect the first time or the second time or the third time, because people are hard. Technology is interesting. So here we go. If I can figure out the right button. So first, why is inclusion important? And these are really my slides here. These are my motivations. 99% of all of our DNA is common. And like any family member, if you're too much like your brother or you're too much like your sister, those differences get to be either exaggerated or ignored. But if we are all so similar, don't we have an obligation to be there for each other, to help each other, use our skills to bring up other people? So to me, this is one of the reasons I got involved with accessibility, to try to do what I can to make the world a better place. So, but first, a personal story. And I think this is important because not many people, there's no one path to working in accessibility. Everybody has their own personal story. Everyone has their own way, and mine is an easy one. I'm a failed musician, but I happened to be raised in Cupertino, California, where Apple Computer was, where I spent 10 years. I worked with the first iPod, on the first iTunes, the G4 Towers, G5 Towers, and Final Cut Studio. Then I had a chance to work on mobile devices. Instead of working on the iPhone, I went to Sony Ericsson and worked on mobile phones there. And then I went to Disney because I thought games were cool, and games are cool. But when Google calls, you pick up the phone. And I picked up the phone. But I didn't start working in accessibility until my second job at Google. My role was the lead technical program manager for Google Play Music. And we had a test engineer that came into our meeting. She turned on her iPhone. We support iPhone. Turned on VoiceOver. I heard button, 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 button. And those of you who know what this means, it's a bad sign. But I didn't know what it meant. So I asked, what's that? And she said, this is Google Play Music for someone who's blind. I said, well, that's stupid. How do they use it? I said, that's why I'm here. So that was my introduction to accessibility, to disability. 18 years into my career, even after failing in music, only then did I hear about accessibility. I can't say that I thought it just happened by itself or it was somebody else's job. I never even thought of it. It wasn't a part of my mentality. But within a couple of months, I volunteered to take on accessibility for Google Play, the whole suite. I spent some time in Daydream doing AR and VR stuff. But then about 5 years ago, I made accessibility my day job. Right now, I am the lead for accessibility and disability inclusion for EMEA, so Europe, the Middle East, and Africa. My job is to try to understand what does disability mean here, there, and bring that back to Mountain View. Because something developed in Mountain View won't work in Mombasa or Mumbai without intention and effort. So my job is somehow to understand this and bring it back so we can make our products better, but how we can also make our platforms better so developers like you can make your products more accessible, or even better, make some really cool assistive technology to change people's lives. So why does Google care about accessibility? Well, I'm lucky. It's part of our mission statement to make the world's information universally accessible and useful. And though Larry and Sergey may not have meant my version of accessible, it's still the same version. We use accessibility to bring everything around the real world, whether digital or the real world, to life, to you, to your friends, and to your family, both on and off the device. So everything from accessible Google Maps. We have a really cool feature called Accessible Places, where we can tell you which places have an accessible bathroom, or an accessible stair, or a lift. I live in England, sorry, an elevator. So we can give you information about the real world around accessibility. So this is about bringing the human experience to people and bringing people out into the world so they can connect with themselves and the people around them. And why is this important? It's because over 1 billion people in the world have a recognized, self-identified version of accessibility. And when you make the effort to build something with accessibility, these differences can be life-changing. But then again, people aren't by themselves. There's people who have their friends and family. So that broadens out the scope even more. There's also a lot of people who don't realize they have an accessibility need. That was me. I didn't realize I had dyslexia until I started doing this work. I just thought I was bad at certain things. I'm a terrible speller. I always forget things. I read the same list 3 times. I get 3 different lists. But I realized this is actually part of my disability. So it might be you, might be your friends, might be your family. Because everybody actually can benefit from a delightful user experience. You might have a phone with sunlight coming down and really bad contrast, and you can't read what's happening on your phone. Or if you have a broken arm, you have one arm. If you're holding a baby or bags, the same kind of thing. So there could be permanent, situational, or temporary disability. And a thoughtful design will support everyone. So when building inclusively, the secret, you always have to make a choice whenever you're designing anything for anyone. The question is, what kind of choices do you want to make? Because there's always going to be a constraint on your project. There's always going to be needs to focus. So if you have to make a choice, and if accessibility isn't part of your way of doing your work, always make sure that accessibility and inclusion are above the line. Thinking sort of backlog language. Make sure it's part of your next sprint. Make sure you never leave it behind to do at the end, because it's always so much easier to do it at the beginning than to add it in at the end. Intention and planning are really important. Think back to me in Google Play Music. Button, 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 button. Doesn't help anyone. You'll have content that's inaccessible. Even hardware. This old Samsung phone, they had the fingerprint sensor on the left-hand side of their camera, which is nice, sort of, unless you actually want to actually take a picture and find you put fingerprint all over your camera lens, which happened a lot. So with a little thought, a little attention, you can create accessible experiences, accessible hardware. Thinking about, say, the metro system here or buildings, there's a thing I call hermit crabbing. It is, like I said a moment ago, it's harder to add accessibility at the end. So if you're building something new, you bring it in. But in English, we have this thing called a hermit crab. I don't know what the name is in French, I'm sorry. But it's a creature that goes in from one shell into another shell, into another shell. And so having to add accessibility onto either a new app or adding on to a new building gets really, really expensive. So that's why this intention and planning is so important. So there are 4 key methods that I think of when it comes to accessibility. The first is leverage your strengths. Do what you're good at. Don't do something that you're just figuring out, oh, I've done a code lab, I think I can do it. No, do what you're good at, because you're going to need to improvise. As a musician, I was good at jazz. You need to be able to play the piano really well. You need to understand the ins and outs to do this in a good way. But the most important thing is nothing about us without us. You'd never want to develop for people. You want to develop for and with people, because empathy is almost a trap in some ways when it comes to disability, because you can say, oh, I know people who are blind are going to have a problem with this. Okay, that's like a 5,000-foot view. The interesting question is, what is the problem that they're going to have? That's a street view. Where are the potholes? What are the problems? And yet, what are the solutions? People with disabilities are profoundly creative people because they spend their entire lives. We spend our lives trying to solve problems because of the culture or society or technology that wasn't invented with us in mind. So you want to bring the people in with you to co-design, co-develop, or at least test the work that you're doing. So nothing about us without us. Develop for and with people. But if that gets scary, because there's a lot of things out there, start with one. Start with one person. Start with one feature. Start with one bug. Just get started. Because it is a language, this is a process. It's about the process. It's progress that you want to shoot for. You're never going to be perfect. So if I can give you one piece of advice right now, never strive to be perfect when it comes to accessibility, because you're never going to get there. Because the web browser will change it from underneath you, or the screen reader will change from underneath you, or the hardware will change, or people will have a bad day. Some people's ability to process information changes from morning to evening. So if perfection is your goal, you're going to set yourself up to have a really bad day. So make sure you move forward, make sure you make it better, 10% better, 10% better, 10% better. It's a whole lot better than trying to be 100% perfect. So what I want to do is share with you an example of this here at Google. And I want to talk about captions or subtitling. So in 2009, Google started with automated captions. And in all honesty, it wasn't very good. But what we learned is 100% of something not very good is a whole lot better than nothing that's perfect. It's sort of that language of perfection, that the progress, not perfection. So we got better, the technology got better, our models got better, and now we have 13 different languages that are supported with automated captions. We had 2 engineers, 2 friends, who worked on the Google Slides team. And they saw the APIs that were being used by YouTube and thought, we can do that. One of them happened to be deaf. So they actually, at a hackathon, built captions for Google Slides because they wanted to do it together. And it was so successful, they actually shipped it in the product, which inspired Google Meet to start adding it into theirs. And now we have 7 different languages for automated captions for Google Meet. And we recently started adding the ability to translate from English into French, German, Spanish, and Portuguese. So we started off with something that wasn't very good to something that's quite good, never perfect, and it grows and grows and grows. And these are server-based products. But what's really interesting to me is how we do this on mobile. So this application, Live Transcribe, it runs on Android if you're lucky enough to use Android, and it provides real-time transcription for over 80 different languages. And if you choose not to or cannot talk back, you can type your answer. So you can actually have a real-time conversation with someone if you can't hear. But when working with Gallaudet, the Deaf University in Washington, D.C., we learned that situational awareness is actually really, really important. So we created models that allow us to detect someone's name or sounds in their area. So if there's a baby crying, or if there's a car alarm, or water's running, we can tell you when these things are happening. And to this point of progress, not perfection, we've just recently released a new version of this that allows you to train it to your microwave or your laundry, because everyone's alarms are different. So now we're allowing someone to customize it to their world, so they can have situational awareness about their machines in their house. It was invented by these two people. There's Dimitri on the left and Chet on the right. And I'm going to let him tell the story.
I'm sorry. Yeah.
I completely lost hearing when I was 1 year old. Technology provides tremendous opportunities to help people with disabilities. I'm a research scientist at Google, and I'm developing speech recognition in technology. Speech recognition accuracy finally became so good that I could fulfill my dream for whole life, to use speech recognition to communicate with people. Hello.
Hello, how are you?
I'm fine, and how are you?
I'm doing good. What can I get you today?
I would like tea. Like Transcribe is an application that runs in Android. It provides transcription of speech for deaf and hard of hearing in real time.
Dimitri worked with the speech team to develop that technology, and Google has made strides in this in the past couple years, but the app itself is what I've been working on.
As an example of those key ways of thinking about it, it's do something you're good at, Google using artificial intelligence, machine learning. It's start with one, trying to solve a problem with Dimitri. Nothing about us without us, Dimitri being deaf. I mean, it encapsulates all of these ideas together. But what's interesting to me is this Live Transcribe application is our most popular dedicated assistive technology. It was also invented by two people over a weekend because they wanted to work together better. So bringing people together, learning to communicate and connect is really important. Continuing down the path of progress, not perfection, Live Transcribe at that time was a cloud-based API. You had to set it up and down from the cloud. And we realized that's cool as long as you have a data connection. And a lot of times people won't. And it also costs money to do that. So we later shrunk the model down to about 500 megs, installed it on the phone, and now we can provide captions for almost any audio source on your phone. It won't do lyrics, though. Don't try. So you can do it for say, social media or audio captions or videos that people send to you. So now people have the opportunity to be involved in the world that's happening around them, even on their phone. And then it gets better.
I hesitated for a few seconds, and I realized the enormity of it, what it really meant. I'm 55 years old, and for the first time, I was able to call my son.
This is Matthew. He likes to swim in cold water.
After a swim, you feel alive.
Like really, really cold water.
I also swam across the English Channel.
But that's another story. Matthew is deaf.
People think if I got a hearing aid on, I could hear everything, and that's not true. I lip read most of the time. I have two boys, and they're both very important part of my life.
This is Matthew's youngest son.
Hi, I'm Harry.
He lives in Hong Kong and plays rugby.
I always want to keep in touch with him. Before, I need to communicate with him through Zoom or WhatsApp. I would try and lip read him, but it's really hard because it's not 3D, it's a flat screen. When I got the Google Picture phone, I could live capture Peter. Harry was the first person I phoned. It was incredible. And we were talking for about half an hour. All of a sudden, he said,
Dad, do you realise this is the first time we've talked on the phone?
I was speechless for 3-4 seconds, and it realised what it really meant. I'm 55 years old, and for the first time in my life, I was able to call my son.
It gets really powerful. Just the ability to bring people together is why I do this. And I still get a little teary every time I watch this video. But we realize there's more that we can do. So recently we announced a version called Live Caption for Calls. So now we have speech to text and text to speech that allows someone who is deaf and or nonverbal to be able to use the phone. So I, as the caller, would type out what I wanted to say, and you can choose what voice you want, and then the person on the other side would hear what's being said. And then you would read what they're saying. Really, really powerful. And then it gets even cooler, and this is why this is really a language of progress, because as technology evolves, we get the opportunity to do this again and again. So in May at Google I/O, we discussed the prototype of some glasses that can provide captions and translation in real time, just like Live Transcribe, but in glasses. And this isn't vaporware. I've tried them on. They actually look pretty good. And even better, they work. So as I've been trying to share with you, find something that you're good at and grow and do it and make it better and better. So leverage your strengths. Nothing about us without us. Start with one. Progress, not perfection. But probably the most important thing is to just get started, because none of this is going to happen until you make that intentional decision to step forward and, okay, I'll make my app, I'll make my service, I'll make my tool accessible. And then more magic can happen the more you do this.
A look can say a lot. A look can be honest and true. A look can speak for you. Say what's on your mind or in your heart. A look can say what's best unsaid and find the right words without having to say a word. A look.
It's great to see you.
Can say a lot.
How are you?
This is what we get to do together. Thank you. And now I'd like to pass the clicker on to Guilaume.
Thank you so much. Hello, everyone. Good evening. I'm very happy to be here to speak about this area, which is something that is dear to my heart. I've been interested in accessibility for a while, although I don't have a particular disability myself. But for example, you can see, perhaps it's a bit small, but I'm interested, for example, in sign language, and I've been learning French sign language. So I'm not a fluent signer or speaker, but that's super interesting, and it opens some very, how could I say that? It's really eye-opening to understand new things, like how people envision the world and express themselves in different ways. And for me, learning French sign language has been really eye-opening, really. And so that's one of the reasons why I'm interested in this topic. I'm a developer advocate for Google Cloud, and we have some great APIs, machine learning APIs, that are useful in various ways. And actually, some of the videos that Christopher showed you are actually using this very same research and technology Google's been working on for years. And those technologies, algorithms, machine learning models are also available to developers. So, for example, who is a developer, considers himself or herself as a developer in the room? Yeah, so perhaps a third or half of the room. So I'm mostly speaking, let's say, for developers to say that you can take advantage of machine learning APIs to improve or help with accessibility concerns, and also for other use cases. So that's how I got started with playing with those things. One little disclaimer or praise I wanted to make is, so today I'm alone on stage to present this part of the event, but I wanted to shout out to my friend Aurélie Vache. Some of you know her in the audience, because that's a talk and some demos that I've done and prepared with her for some other events. And so yeah, thanks to Aurélie for this common work together on machine learning and accessibility. So why this talk? So we've seen some different figures, but that's roughly the same kind of figure we have. If you look at all the French inhabitants, 30% of persons are actually impacted in a way or another by a form of disability. So they don't necessarily have some kind of disability, but you may be someone helping someone with a disability, etc. So really, 30%, in my opinion, is not that much. I'm sure you've all had to help someone at some point with some form of disability. So disability is really not, something for a minority of people, but it's really something that touches anyone, rich, poor, young, old, or any person can be affected by that. And disability doesn't necessarily affect you today, but at some point later on, it might affect you. So you might be, as you grow older, you can lose sight or hearing, of course. So really improving accessibility helps everyone, and it might help you in the future, right? So I'm sure all of you here are interested in the topic, so it's a top concern, it's top of the mind, but it's not necessarily the case for everybody. But as soon as you start, thinking that you may be affected, perhaps those people who are not thinking about it today may be thinking about it later on. So I illustrate this slide, with this ramp where, okay, I don't know exactly where this picture was taken, but some kind of big museum, and there's a big ramp to go upstairs, right? So you may have elevators, but, well, to go from one room to another, a ramp might be useful for people who are in a wheelchair, for example. But if you're a parent with kids in a stroller, or if you've broken your leg, perhaps you'll be happy to have this ramp. So, of course, we're focusing on people who have some form or another of disability, but implementing accessibility will help others as well. So it's important to keep that in mind. And developers often think of accessibility. They think about things like, especially web developers, about just adding alt tags to images on web pages. So it's a first thing, and Christopher mentioned that, progress. You start small, perhaps, but then you can add stuff later on, right? But there's more to accessibility than just alt tags, right? So it has to be, a constraint from the get-go, from the beginning, rather than be an afterthought. And I've, in my past life as a consultant, although I wasn't really an accessibility specialist or anything of that kind, but I've seen many projects on which accessibility was an afterthought, and adding that later on in the process of development and design of a product is usually much harder. So it's better to think about it from the beginning. And what else? So there are new technologies that come up. So I'm thinking about things like voice assistants. We have a Google Home Mini on this picture. And, it's great. But of course, if you have some speech that is different than others, perhaps with an accent, perhaps because you are stuttering, etc. Well, try to use those kind of devices. It's a bit of a nightmare. So we are working, and Christopher showed Dmitry on screen in the video earlier, but for example, his team and himself, they're working on some speech models that understand people with a different kind of voice, with different accent, with stuttering, etc. And soon, those kind of devices will be helpful for people who speak differently than we do. So, a little bit of a disclaimer. I'm not a machine learning expert, but my point tonight is to tell you that although you may not have a PhD in machine learning, etc., you don't have to have that PhD to be able to do something useful and add some useful feature in your application thanks to machine learning APIs that are available off the shelf. So we'll see in this presentation some use cases where I'm showing how to use those APIs and where they can be useful, and not just for accessibility, but helpful for everybody. So without further ado, I'll start with a concrete demonstration of one of the great machine learning APIs that is available as part of the Google Cloud API offering. I'll be showing the Video Intelligence API. What's interesting is that it allows you to make sense of the content in videos. But in videos, you have, of course, the images, but you've got the sound, and in the pictures, the frames of the videos, you also have text, although it's not text that is spoken, right? It's text that is displayed, so you have to understand what this text is doing. So, yeah, you can, well, I'll dive right into the demonstration. So let me get that page ready. So let's switch the screen to show this demonstration. All right. So this is a demo application. I think I'll just show you right away with the video.
It's a rough and tumble area just outside Pittsburgh. My name's Scott Baker. My family has been connected with this community for generations. In 1941, my grandfather opened his bakery here, and he called it Jenny Lee.
We used to always go to Jenny Lee's after church, if you were good.
So I'll just stop right here because I don't want to put the 4 minutes of the video. But what's interesting is that this demonstration, and I'll show you the various tabs here, is able to use the Video Intelligence API pretty much fully and show the different features of that API. So for example, the one I wanted to show live, it's this one because it's interesting. You see the live progress of the speech that is being recognized, what's being said in the video. So you see each paragraph, and then underlined in red, you can also see the word that is currently spoken, because the video is able to tell you, okay, there's this word at this time code in the video. So you know exactly what is said at all times throughout the video. What else can you do with the Video Intelligence API? You can see the labels. So labels is really about recognizing what's in the picture. So for example, I can see at some point, I think I can move to the part, well, perhaps it has to be, just need to press for a second. You can see, for example, a road street at this point in the video, this other point, etc. So it's going to tell you all the things that it sees and understands in the video. So there's a car, someone speaking, there's food in different places of the video, some inventory because you would see shelves in the background, etc. So you can see what's in the video. You can have also a shot detection, meaning the different scenes in the video. So you can cut the video into smaller parts. There's also object tracking. So for example, when there's, let's say, a bridge, you see that the bridge appears here and there, and the person, and you can also get the position, I think if I remember correctly, of that thing that was recognized in the picture. Person detection, when there's a picture in the person in the picture. Face detection, so you can see, okay, if like the position of the face, whether they have glasses, etc., some headwear, and so on. Logo recognition, so are there logos recognized? Speech, I already showed that. And also text detection. So for example, you can see sometimes, let's say there's a maybe there's a sign at some point on a you know, I don't know, the name of a shop or something. You can see the text. It's like OCR basically. There's the text that appears on screen. And what's left? Explicit content detection, so that's places where potentially there's content like profanity, you know, content that you wouldn't like to show publicly. So you're also able to filter that kind of stuff. So let's get back to the presentation. Thank you. So this is a demo of made by my colleague Zach Akil, who's in the London office. If you want to see how to implement something like this, it's actually for those interested, the code is available as open source, so you can reach out to me and I can share the link. I should have shown the link on the slide. I'm sorry. The code is open source, so you can have a look at the code that does this, that is using this video intelligence API. What's interesting is that, and that's the real code. The biggest part of the code base is, of course, the let's say the GUI, you know, the visual stuff to show things on timelines and such. That's more complicated than actually calling the video intelligence API. That's the code that you see here. So it's in Python. And really, it's pretty declarative. So for example, on the left pane, you can see the list of features of the video intelligence API you're interested in. So for example, object tracking, label detection, etc. So declaratively, you say, OK, I'm interested in the feedback on you know, knowing the objects that are recognized, etc. And then, well, it's really about configuring, like passing the source of the video, etc., and calling the annotation method that returns all the a huge JSON file containing all the information that you show on the demo. But really, that's not that much code, not very complicated to do. So with what else? Yeah, with speech recognition, you transform recorded speech into live speech, or live speech into text. So when you have some hearing difficulties, instead you can read the transcription of what is spoken, even in real time. But of course, it helps in many other situations as well. If you can, it can allow you as a developer to make vocal content searchable. So for example, in the video earlier, I'm able, you know, like in a search engine, Google search, I can type and find something in the video instead of having to look at all the content of the video or many videos. You can search through that without listening to everything, and it's going to tell you, okay, this particular, you know, word that you're searching for is happening at that particular time code in the video. It can be useful not just for accessibility, but it can be useful for things like call centers. So if you want to, you know, search for particular problems with your product that users and customers are reporting, you can search through podcast, and I'll come back to that in a minute about podcast, or through your voicemail archive on your phone, for example. Imagine you're in a meeting, you've got a phone call, someone records a message, and if you can read, you know, discreetly, I got a little message. Okay, so you can read the message on the voicemail. But another example is when, really when you're in a place where there's lots of noise, you're not going to be able to listen easily to the content, or also, let's say you've got a, you know, you really want to watch this Netflix series or whatever, and you've got your baby that just fall asleep, you're not going to put the volume on. So having transcriptions is also helpful, even if you don't have any kind of hearing disability. I'm going to say a few words about the speech to text API, which was released. I think that was one of the first, or was it the Vision API? I forget. It was one of the first machine learning APIs that were released in the list of machine learning APIs from Google Cloud. It supports more than 100 languages and variants as well. So things like different accents or British English versus American English. It's really great at noise filtering, especially in a noisy content. You're in the metro and there's lots of noise around. It's still going to be able to understand what you're saying. There's profanity filtering. What else? You can do. So it knows about various file formats, MP3, etc. It can also do a live stream, so you can get the transcription, as the speaker is saying stuff. Also, what's handy is that you're able to help the API by providing some custom phrases or words or technical terms that will appear. So for example, I'm a developer, so I often use technical terms and acronyms of some technologies. And if I can, feed the API with some vocabulary that may happen, that may appear in the audio content, then it's going to also improve in terms of quality. The last feature I'd like to mention, it's the diarization. Never know how to pronounce it correctly. Diarization is the ability to recognize different speakers. So it's great to have word after word of what is being said, but if you don't know who said which word, it's going to be complicated to really understand a dialogue between different persons. So rather than returning just a pure flow of words, you're going to have some streams of, okay, this speaker is saying this other speaker is saying that. There are client libraries for many languages: Java, Python, JavaScript, C#, PHP, Ruby, etc. There are two kinds of interfaces: REST and gRPC interfaces. The client libraries usually use the gRPC interface because that's the most powerful one. And you can do both synchronous calls to have the answer right away. So for example, if you send short portions of audio, or you can also do batch. So for example, you've got a podcast recording which lasts for an hour, and you send that content, and then you're going to wait for a certain amount of time, like 5 minutes, 10 minutes, I don't know, to get the results of the transcription. So yeah, there are those two forms, the recognize method and long-running recognize. That's the difference between doing the synchronous and asynchronous call. That's about it for roughly how it works. And speaking of this, perhaps some of you, the few who might know me, I'm part of a podcast, Les Cast Codeurs. And so this is our team. And so our podcast is not really accessible to people who are hearing, hard of hearing or deaf. And I was curious if we could try to automatically provide transcriptions for our podcast. And the thing is, so we provide show notes, right, with links, short descriptions, etc. But it's not enough to make a podcast accessible because you just have, the links and what we talked about, but you don't have the actual discussion about each of the items. So that was complicated before because there was no diarization. So when there are 4 or 5 persons speaking, you've got this flow of words and you don't know who said what. That's a bit complicated. And also the other thing that is complicated is that since it's a tech podcast, you've got words, technical words, acronyms, product names, etc., which are very specific to the topic we cover, but which is not necessarily content that is recognized by speech-to-text APIs. So I was curious to see how it would work with our podcast. So I went to the Google Cloud Console. I went to the speech-to-text API page. Then it's not very complicated. I gave the link to the MP3 of one of our episodes. Then I said, okay, it's MP3. You've got the sample data rate, number of channels, if it's stereo, mono, etc. Then I think it's on the second screen where you can also specify things like the language that should be recognized. So some of those parameters are sometimes hints. So for example, I think it's at the bottom. You can see the number of speakers. It's a hint to help the API. I think there should be 3 persons, but perhaps there are 4, etc. But it's really a hint to help distinguish between, for example, for the diarization, to differentiate the different speakers. And third step, model adaptation. For example, there are different models that are possible. For example, if it's content that is coming from a phone call, you don't have the same quality, the same kind of model, underlying model. So you can choose between different models. And then you can also feed, as I said, some words, technical terms, acronyms, etc., that might be appearing in this episode. And the result of this call is going to return a huge JSON file with the time code of each and every word that is recognized. And also, for example, here on the right, you can see, okay, there was the word merci. It appears at 4,734 seconds, you know. So you've got the details. And also look at the speaker tag 1. So that's the first speaker that was recognized. And I have this little script that parses the huge JSON file that is returned in order to create this output here. So don't bother too much about reading the details, but I highlighted in different colors the different speakers. And for example, the big blob here in red was speaking about, so I'm a Java developer, about the Java Development Kit, the JDK. That's an acronym. But it worked well. It recognized the word, or the acronym JDK, you know. Although I think we probably said JDK, of course, because we were speaking in French. But sometimes there are things like, so if you just read the first line, la licence, donc c'est un JDK officiel, nos amis de adoption homme, human adoption. What is that? Why are we speaking about this? But actually, here it's a project called Adoptium. So it's kind of not really a Latin word. I'm not sure if it's Latin or not or what. But it understood something that is pretty close. Adoption homme, adoptium. Yeah, that's pretty close, but that's not it. And really, when you are reading automatic transcription, it's never perfect, okay, granted. But still, sometimes, when you're trying to read this without the overall context, you might be stuck at, what are they talking about, you know? So, you know, it's not perfect. It's not bad. It's better than nothing, but it can still be improved. So often I'm saying that machine learning APIs can help with accessibility, but it doesn't mean that it's replacing humans for that purpose. It can help with, for example, the first draft. So the day, I haven't done it, but perhaps someday I'll automate this to add automatic transcription to our podcast. But if I do that, I'll ensure that this will be the first draft, automatically generated. It saves me a lot of time. But then it's always better to have one human being actually, and not an adopted human being, you know, a real human being going through this and fix all the errors, because a human being, of course, knows the context that is being shown. And really, the speech recognition level, like this is a graphic of the word error rate, has improved tremendously. So before, almost one word out of, let's say, 10 or perhaps less, the API was getting it wrong. But now we're at like 4.9%. So it's probably not 2022, but close enough. It's, this graph is probably 2 or 3 years old. So it's not recognizing 100%. compared to, let's say, human beings actually don't understand 100%. For example, if you're listening to lyrics in music, if you're in a loud and noisy environment, you probably don't understand everything that's being said. But the human brain, is able to interpolate and understand, depending on the context, what's actually being said, and figure out the missing words that are not said. So again, it's great for a first draft and human intervention later. You get a nice and great transcript. So speech to text, but what about text to speech? Text to speech, that's the reversibility to transform written text into a natural sounding voice and speech. So there are different kind of voices that are available with text to speech APIs, and there's often SSML. It's a feature, let's say it's a markup language where you can say, okay, I want to make so it's a syntax with a bit like HTML tags where you can say, okay, I want to make a break here, I want to put some emphasis on this word, etc. Or choose like the speed of the voice, the pitch of the voice, so you can tweak the voice that is generated. But it could probably be, better. And for example, the natural, I think I'm mentioning that maybe later on. We're using actually in the text-to-speech API on Google Cloud, we are using new voice models which are developed thanks to machine learning. Before, we had something that was more of a puzzle of phonemes that were stitched together to generate some kind of voice. But now it's really human-sounding voice, really. And that's the folks from the Google DeepMind team who worked on new voice models called WaveNet, which really generates super realistic sounding speeches and voices. And of course, so if you want to generate speech from text, you've got an API, the Cloud Text-to-Speech API, which offers 200 voices, different variants. You can, change the pitch, etc. And again, you've got client libraries to facilitate the integration. And that's, under the hood, that's the same kind of technology that you find in TalkBack, like in the Android accessibility feature, again, that Christopher mentioned as well. And I've seen something those past couple of years, maybe, it's that there are more websites with a voice, let's say. So for example, here's a screenshot of the Numerama website, news site. And so I have no idea if they are using Google Cloud text-to-speech. They may be using a competitor API, but it doesn't matter. The point is that you can get someone, a robot, okay, but to read the actual article for you. And that's pretty cool because it really sounds like you and me reading the article. And not only is it useful for people with some level of visual impairment, but it's useful as well for, let's say, me, I'm cooking, so I'm doing something else. I'm not going to read and cook at the same time. I'm sure to, cut my hand or something. I've even managed to do that. I burnt my hand very aggressively when trying to watch TV at the same time as preparing some jam, and that's a true story. So really, I really like the creative use case. So it's helping, of course, someone with an impairment, but it can also help you, like when you're cooking, when you're running or something. And I'd like to highlight as well the creativity of developers. For example, I'm not familiar with that game, but there's the Hearthstone game, a card game online. Some folks created a mod, so a modification and a plugin to the game with text-to-speech, so that blind people with low vision can actually play the game without really seeing, the cards that are exchanged. So it's really great to see the creativity of developers and how they can improve existing games that were not designed with accessibility in the first place, and add that later on at a later stage, as a community contribution. Another creative use that a colleague of mine, Dale Markowitz, who created that, and I think that was during the pandemic that she created this demo. So she used that API again to transform PDFs, potentially of articles, etc., into audiobooks. So your favorite stories, your favorite articles, and you feed the PDF, and then you've got the sound, the speech of what is said in those PDF files. So that's a pretty cool and again creative use case. I'll finish with a few words about that's the last API that I'm going to mention, the Cloud Vision API. So this one, I think it's a picture of Aurélie's cat, for those who know Aurélie. It's the Vision API. So pretty much like the Video Intelligence API, so you can do things like object detection, label detection, text detection, the color palette if you want to know more about the properties of the image. And also, for example, if it's a picture of a famous place, you are able to know where this picture was taken. And I'm going to switch directly to a demo. So this is an app I did for a conference and a workshop, and on the right you can see, for example, the output that is given by the Vision APIs. For example, well, there's no cat in those pictures there, but if there's a cat in the picture, you're going to see, cat, like is it safe to show, or the kind of colors that appear, etc. So let's switch to the. I need to unlock my screen first, of course. Yeah, let's switch. Thank you. So this is an application that I built for workshops and for conferences, etc. And this one is actually a fork of the original application that I built, where I integrated the Vision API with Elasticsearch, which is used as the database and search engine for my application. And what's pretty cool is that, how it works, in a few words, I'm actually storing all those pictures. Then I'm calling for each picture the Vision API. It's going to return lots of information, what's contained in the picture, the colors, etc. And then I'm able to index that thanks to Elasticsearch, and then query that again through Elasticsearch. So people have uploaded pictures of tons of things. Oh, there's actually a cat. That's my cat, right? And so you can see, if you look at the labels, you're going to see things like cat, comfort, yeah, looks like so, carnivore, whiskers, Felidae, etc., snoot, tail. Right. It's a domestic short-haired cat. I confirm it's a domestic cat. And also you can see perhaps, let's say, one with some bright color like this. It's a nice color. I can actually search with colors. So for example, I can choose this one. I should see pictures, or perhaps, let's say, some red, strong red color, orange. Let's see all the orange colors, or those teal kind of color. I'm not sure how to call these colors. And I can also, of course, so for example, we know there are cat pictures. We know that perhaps I can refine my search as well. So for example, pictures which contain water. And I really like this color very much. So I can filter with different things. And I can also click on those things like I want to have a lake. So it's going to reduce, so it's like faceted search. And really it's very easy to add that kind of feature. So as usual, I'm a backend developer, so adding the visual component to click and do that stuff is hard for me, but calling an API is very, very easy. So yeah, that's about it for this demo. Let's switch back to the slide. And again, that's the Vision API allowed me to make those pictures searchable. Imagine you've got millions, billions of pictures. You're going to be able to search and understand what those pictures are about, even if you can't see them at all. And if you think about it further, imagine that you want to enrich. So we often, web developers, think first about alt tags on images, but yeah, you could use those labels to fill the blanks of missing alt tags or ARIA attributes, etc. But then to go beyond, of course, instead of just showing person, guitar, sofa, etc., it's better if you have sentences. So if you say appears to be, it's because it's not 100% sure, but it's saying person playing guitar on the sofa. So there was an article 2 or 3 years ago about this. That's the link that is displayed here. But really, it's interesting because those APIs or more advanced machine learning models like this one can help with accessibility. It may not be perfect, but then human beings can make it much better afterwards with a second pass. So to conclude, as I said, you don't need a PhD in machine learning to take advantage of existing machine learning APIs to help improve accessibility. It's not replacing human beings, accessibility and usability experts. It can be a complement for their work, and it can help kickstart accessibility efforts. So really be sure to check out those machine learning APIs offered by Google Cloud, and not just by Google Cloud, but also our competitors. They are doing great work as well. And because I want to get out of the machine learning bit for a few seconds. Sometimes, so there's accessibility, like web accessibility, of course, alt tags and so on, making contrast in your UIs, etc., bigger buttons and so on. But sometimes there are small things that help people. For example, I hate making phone calls. To get an appointment for something, I may spend weeks before calling because I really hate taking an appointment. And with the invention of sites like Doctolib, I'm able to just go to a website and this specialist there, I want to have an appointment. So think about the different ways people can interact with your product, your service, etc., offering different means to access the people, the product behind. That's useful. And one last example, that's those machines on the right at the McDonald's. Same thing, for example, so I speak English not too bad, okay? But the truth is that if I go to the United States and there are people with a strong American accent and noisy environment, sometimes I don't always manage to order something at the McDonald's because, wow, what? Oh yeah, take away. What? Which size? How do I say? Then they, well, you know the story. You go abroad, etc. But then there's those kind of machines which also help me. Although I managed to speak English, still sometimes it's hard. So thinking about different ways of accessing your product also helped a long way. So that's about it. Thanks for your attention.
And it's time for our next and final speaker. I'd like to introduce Emily on stage. Thank you, Emily. The stage is yours.
Hello. Oh, wow, okay. Hi, everybody. My name is Emily. I'm very excited to be here in person, especially with you all today. I'm usually based in the West Coast of the US, so I really appreciate the opportunity to come to Paris and talk about something as important as accessibility and building for everybody. I've been a software developer at Google for 3 years, and the whole time I've been working on the Maps JavaScript API, which is under Google Maps platform. The past few years, my team has been working on making our API more accessible, and I'm going to be diving into our approach, and hopefully you can apply what we've learned along the way to your projects. Before I dive into how our team approaches accessibility, I wanted to give some context around what Google Maps platform is. For any folks in the audience, can I see a show of hands of who has used Google Maps before in their day-to-day life? Has anyone developed with the Google Maps platform before? I see a few hands. Cool. So basically, for those who aren't familiar, we provide a wide range of visual components and data through our APIs, which are roughly organized into 3 categories: maps, routes, and places. I've primarily been focusing on the JavaScript side of things, but we also offer Android and iOS SDKs as well as HTTP web services. Most of what I'm talking about today will be applying examples to JavaScript, but these can be used, like all of what I'm talking about can be used for all these platforms. So a few examples of what you can do with GMP is providing a wide variety of UI components to our customers. They're usually populated with information that's also available on our consumer applications, aka maps.google.com, or the Android or iOS applications. One example is our base map, which provides general geographic information. On top of the base map, you can add a marker or an info window to highlight specific places or add their own content. On the routing side, we offer a directions component that populates turn-by-turn directions between point A and B and also shows the route on the map. We also have Street View, which customers can choose to have displayed by itself. It can be side by side with a base map, or it can just be opened on top of the base map after a user drags and drops a little yellow Street View pegman. We also have an autocomplete widget, which can provide place or address suggestions based on what the end user is typing. These are just a few of the UI components we offer, not including our pure data APIs like geocoding, place elevation, and so on. Okay, our customers are hardly ever using just one of these components. Usually they combine several of them to create an entire page, for example, a store locator. Our customers have their own customers, which on our end we call end users, that might want to know where they can shop in person. So our customers who are developers can use our base map API, our marker API, and our place autocomplete API to build a store locator page. And users can type their address or location and give back information on the closest store to them, like opening hours, directions, and so on. Depending on their needs, customers can add or remove some components and configure those components in dozens of different ways to optimize the end user experience for their application. So now that I've gone over what our reusable components are like, I'm going to discuss how my team approaches making them more accessible. Like, how do we choose what to work on, what not to work on in terms of accessibility, and also some other aspects of our products that need to have accessibility be considered beyond just our reusable components and UI. So our components are meant to be used in combination with each other, and they can be used for dozens of different use cases, not just a store locator. And within the same use case, different customers can choose to use and implement their solution in unique different ways. So in our case, our team has been working on accessibility improvements for the past few years, but our APIs are over a decade old. We've had some catching up to do. And with such a large API and so many different ways our components could be put together, there was no way we could make everything accessible right away. We've been working on it since I've joined, which is about 3 years, and we're still nowhere close to being done. And so we decided to take a look at popular applications that are using our components and break them down into its different pages or screens. Even if you aren't an API like us and you have your own standalone app, you can apply these steps as well. So first, figure out which of these pages experience the most usage, and then focus on testing that page alone for accessibility. Some examples that we have been looking at are store locators, address forms, things like that. And if there are components on that page that are causing accessibility issues, then you can prioritize making improvements towards those specific components. Once you've made good progress on the most popular page, then we can repeat this flow with the second most popular page. Assess the page, find accessibility gaps, and then make the components on that page more accessible. I would like to point out here, there's no perfect definition of an accessible page like we've been repeating throughout this entire talk. Perfection should not be a blocker on moving to the second round of assessments. I'm being very careful with my wording here and saying improving accessibility, making this more accessible, rather than just saying this is accessible now, or this is 100% accessible. Because it's better to get what you have out there and available to your end users sooner rather than later. Even one small change can open up your product to a whole new audience of people. That lesson was especially important for us in GMP since we had a lot of pages to address. The first one seemed so scary, even though we narrowed it down to just one page. There were a lot of accessibility bugs that we needed to tackle, and we were basically starting from zero. However, one perk for us for having reusable components is that more often than not, Screen 2 will have some overlap with Screen 1. And luckily, we've already worked on accessibility for that component when we were looking at Screen 1. For example, a store locator page and an address form both utilize the autocomplete widget. So we already did most of the work in working on Screen 1 for the autocomplete widget to make Screen 2 more accessible. So if you already have an existing app or website and you're sitting there thinking like, oh no, there's so much work to do, don't be intimidated. After that first page, it just continually gets easier and easier as you go. Ideally, though, you should be thinking about accessibility from the start of development. It's not nearly as hard as doing things retroactively like we've been working on. The process when you're starting from scratch is kind of similar, but you kind of have to think about how do you intend for your component or page to be used and verify that those usages have good accessibility. But if you're developing components that are going to be used by other people than yourself, you also need to think, what are some other reasonable ways that you can see other people using your component? And let's try to make those use cases accessible too. But we don't want to try to cover every single edge case that you can possibly come up with. I'm sure there's some super niche usages, but like I mentioned earlier, we do not want to block progress on perfection. We don't know if these edge cases are actually going to get used. So sometimes a better use of time is to address the most common usages, put what you have out there in the wild, and ask for feedback. Watch what the customers are building, see if any accessibility bugs have been reported, and then you know what to prioritize in your second round of accessibility work, and your third and fourth, and so on. So one of our team's goal is to make sure our customers, who may or may not be dedicated developers, our goal is to make sure they do not have to do a lot of work to use our components and make it work with their page. That applies to accessibility as well. So we try to provide as much accessibility as possible for the most common use cases, but there are a few situations where we need to ask customers to do it. I'm going to apply a few examples to an info window, which is the component we can add to the map. Most commonly, the interaction goes like an end user clicks on the map, an info window with some customer-provided information will pop up. The end user can read the info and then close the info window if they like. So a few examples of what we provide out of the box: appropriate semantics. Info windows are components that appear and disappear from the map. So communicating that an info window is a dialogue. We'll make sure that our users who use screen readers and don't necessarily have that visual feedback, they'll be able to know this is something new that they can interact with. In JavaScript, communicating this to screen readers is as simple as setting an HTML property. So it's like 30 seconds of work. Another critical interaction here is keyboard navigation. We have users that rely on keyboards to use any form of technology and can't necessarily use a mouse. So we need to make sure that the info window can be used with a keyboard. And for mobile examples, they have to be available for there are switch devices and a lot of other accessibility tools that can be used. We also have, so we've added a dedicated close button to the top of the info window that is keyboard focusable. But if there's a lot of content, for example, they have to tab through all that content and then tab a bunch of times back through the content just to get back to that button. So providing a keyboard shortcut like the escape key provides a quick and easy way to close the info window from anywhere inside the info's content, and then they can just move on to the rest of the page. Color contrast is another thing that helps makes our components accessible. Obviously, our default colors should have good color contrast, but computers and phones often have high contrast modes that are set at the browser or operating system level, and our end users can set their own colors that work best for them. For example, if you're red-green colorblind, then obviously they will set something that is not red or green. The background colors can also, that are typically very good high contrast, can be like a black background with white text or yellow text. But if we've hard-coded our colors to be, say, we want our black background to be white and we want our text to be dark blue, then these user-specified colors might not actually show up even though the user has requested them at the browser or operating system level. So we made sure to support these different color contrast modes by saying, like, this is our light color, this is our dark color, and that's something that these tools are looking for to switch to, like, plug in these new colors that the user has requested. One thing that's generally good for modern web development but also makes a great impact towards accessibility is responsive design. Some users need to use bigger fonts or they need to zoom in by 300% in order to see what's on the screen. Responsive design can adjust to those different sizes and make the info window scrollable when the content starts getting bigger than the info window's bounds, which will ensure that the rest of the content can still be read. So it's also good for localization because some languages tend to use a lot more characters than others. Does anyone know German? I usually am building my examples in English, but we also test in German because it tends to take up a lot more space to say the same thing in German. So what I'm trying to stress here is that oftentimes good coding practices will make your app more accessible for folks without doing a lot of extra work. And I mentioned earlier that we do not want to block progress on edge cases. However, we also don't want to block developers from building that edge case if they're really determined to do that. So if our best guess doesn't work, and we've given the option to override and turn off those features. For example, our info window comes with an automatic keyboard focus management. When you open the info window with a keyboard, focus will automatically jump to the marker from the marker to the info window's content. And when we close the info window, we return focus to the marker. If that's not what the developer wants to happen, all they need to do to turn that off is set a property called shouldFocus to be false, and then they can go ahead and do whatever they like instead. So we've done our best to make our developers' jobs as easy as possible, but there are some cases where they need to do a little bit of work, please. Our info windows start out empty, that's what we give them, and developers can fill it with whatever content they like. We don't know what the content consists of, so we have to ask the developers for the accessibility label. In our JavaScript case, we ask them to provide us with an ARIA label, which we then pipe to our HTML, which can then be read by screen readers. In the example I have here, we have Lassen Volcanic National Park, which is a national park in California I have never been to. But we've asked our developer to pass in an ARIA label, Lassen Volcanic National Park. In this case, it is the same as the title of the info, like the title caption of the title heading, of the info window, but there are some situations where that's not the case. If, for example, they choose to put Lassen Volcanic National Park third in the HTML DOM sequence, then we don't necessarily know that that's the most important thing, so we can't just guess that the first thing that's on inside the content is going to be the best descriptor for the content as a whole. And one thing to think about outside of just UI development is that Google Maps platform is not just UI. We also provide data APIs. Google has so much information about the world around us. We also have the power to gather the information we don't necessarily have yet. We were talking earlier about some photo ML for alt text, right? So if we have data that is helpful for our customers, like accessibility text for photos that show up in place reviews, or if this place has a wheelchair accessible entrance, or if this bus route has a ramp for wheelchairs to get onto the bus, we have a responsibility to communicate that information to our customers and users, not just our direct consumers. And we are also an API. We have developer resources for our customers that they often use as a starting point to use our components. And we've done all this accessibility work for our end users. We want to make sure that our customers are utilizing them. So making sure that our code examples, which sometimes just get copied and pasted word for word, have these accessibility features enabled, and will hopefully increase the amount of end users we can impact. And if our end users do find bugs, make sure that the issue tracker is accepting accessibility bugs and feature requests so that we are aware of our gaps and how our end users want to use our components, and we can consider that in our next round of improvements. And developers are end users too. They use screen readers too. They might use color contrast settings as well. So our developer guides, our code samples, our documentation, our tools and platforms that are in Google Cloud, they need to be screen reader friendly. They also need to respect color contrast settings too. And especially our issue tracker. If our users find bugs and they can't tell us because the bug reporter isn't accessible, then we're really not doing a good job here. There's no way we can continue to make progress if we can't get that feedback from our actual users. So we are nowhere near the finish line with respect to accessibility. Making our platform accessible is an ongoing journey, and we'd love your help with understanding where we are. I've got a few links here that where you can file new bugs to put things on our radar. You can also +1 existing bugs so that we know what we can prioritize next. And if you'd like to keep up with our progress, I've also got some links to our mailing list, blogs, and our weekly release notes. I think we've caught up on time.
All right, thank you, everyone. First, thank you so much to all of our speakers for joining us. We actually only had Guilaume, who is Paris-based, so thank you everyone else for traveling. If you are interested in joining more of this accessibility campaign that we're leading, you can check out this website, so go/accessibility-join. Or if you want to receive more news from our team, so the Google Developers team, for events similar to this, you can also join our /dev-Europe-updates. And so with this area specifically, we will send one-offs, invites to events similar to this, based on where you are located, or if it's events online. So it's not like a quarterly or a monthly or whatever newsletter. It's really one-offs based on topics. You can select topics that you are interested on. So for example, Android or Flutter or something like this. So you would only receive information on either your locations or topics that you are interested in when you sign up. And with that, I'd love to invite you to the networking so you can chat with our speakers and with each other and enjoy some snacks and drinks. Thank you so much for joining us.